Hello Professor, this is Carl Crook and I'm going to show you my PA4. First to run it. Okay, so we got 5 by 11 aliens. As they hit the sides, they bounce back and forth. So we have a timer event manager, which is a singleton. It takes in timer event objects, which takes in a command object, and the command is run with the process method on the timer event object. So I add in 3 timer events. One is for the squid that's going to cycle through the squid's animations every 0.5 seconds. I have another one for a crab, which is at 0.5 seconds, and another for an octopus, also at 0.5 seconds. When I add to the timer event manager, I'm going to add in sorted order, the same idea as I did with sprite batch manager. If the list is empty, we just put the timer event just straight in there to the front. Otherwise, we're just going to be walking through the list until we find the appropriate spot to just insert our timer event into. That will keep the list in sorted order. When we call update on the timer manager, I'm going to show you an example where we're going to do an early out. So I'm going to give it 0.3 seconds in for the update time. It's going to compare that against all the other events, which is going to execute at 0.5 seconds. So we should be exiting immediately. Once we're running into update, as I set a breakpoint, we can see that the current actual time is 0.3 seconds. It shows up. And once we hit our while loop, once we start iterating through our list, we're going to see that the very first timer event is going to run at 0.5 seconds. And since we didn't hit 0.5 seconds yet, we're just going to exit the while loop immediately. And there we go. To talk a little more about the commands, I created a concrete sprite animation command, which upon construction, it takes in an initial image and also a initial sprite image, which all the other proxies will be referencing also. I also have an add method to add on more images. This class is going to be managing its own list of images through image slink, which inherits from slink, which is just a singly linked list. It just has a next field. This class also has its execute method, which in this case it just sets the sprite to the next image in the list, fixes up the list, and then it just adds itself back onto the timer. This class inherits from the abstract class command, which that class just has the abstract method execute. And execute is called in the timer event whenever the timer event is fired off. The process method will be called, just to show you. The process method is called, which calls the commands execute, whichever commands it's referring to. Now for the composite section, I set up my aliens using composite nodes and leaf nodes. For my composite pattern, I have the top class component. Underneath component is the game object, which inherits from component. Underneath game object, we can either have a leaf, which inherits from game object, and underneath leaf, we have concrete classes such as a squid game object. I also have one for crab and octopus. Or instead of having leaves, we can have a composite nodes, which also inherits from game object. Composite manages its own list of components, which is members of component D-link, which is inherited from D-link. And of course, we have the add method for the composite, which allows me to add more components onto the list. All the aliens live under alien grid, which is a game object. Alien grid takes in root. Root is a composite object, and on that composite object, it has our 11 columns. Each column has its aliens populated by a factory I created. It's an alien column factory, and each one is going to be created with a getAlienColumn method on that factory. The getAlienColumn method on our factory is just going to create our 5 aliens that we see in each column. It returns a composite of the 5 aliens, and it also adds our game objects into the game object manager, the 5 aliens. And for the extra credit, I created an iterator that I'm going to use to go through my alien grid. I have the abstract class iterator, which has our 3 methods, and I created a concrete class composite iterator. Once we set up our iterator to the alien grid, I'm going to use the three methods as shown in class, starting with the first method. Inside the first method, I have a return to parent variable, which is specific to my implementation of it. Just to show quickly, the example you've given us, your component class inherited from D-Link, but mine doesn't. And I do it a little bit differently to make the iterator work, which I'm going to show you right now. Really quickly, the next one we do is done, which is straightforward. We just check if it's null. There's our check for null. And now for the next method. Next method right there. When we enter next method, let's say the next node we see is going to be a composite node. We're first going to check the return to parent. The first time we enter a composite node on the iteration, it's going to call reset iter, which is a specific method I have on the composite class. I have three extra helper methods for the iteration. Basically, reset iter is going to set the iterator to the front to start fresh after a previous iteration. Then we're just going to walk through our composite with get iter and advance iter, returning the component associated with each node. Then once next runs, we're going to go back through our loop again. We're going to check is done, and we're going to call whatever function we wanted on our component. Once back in our next method, if the node we were looking at is a leaf, it just simply returns back to the parent and sets return to parent equal to true, since a leaf node is a terminal node. When we go through the next method again, we're going to end up back to a composite node from our leaf node. And in this case, the return to parent is true, so we're not going to end up resetting the iterator. We're just going to keep going through our list, and we're just going to keep walking through a composite node like that, getting the next node until eventually the composite node will have to go back to its own parent. Eventually, the parent will be null, and that's how we will end our iteration. One last thing, my game object class has a proxy sprite member, and a proxy sprite, we can have many proxy sprites, and it basically references a shared image sprite. And of course, proxy sprite has its own proxy sprite manager. And the game object will have an update and render function that I had to implement. I would find it in the leaf. For update, I just push to local variables x and y, local to my class, and then in the render, I push my x and y to the proxy sprites x and y, and then I draw the proxy sprites.